Hello, they're so close. Nico, can you make this video? Nico, I'm gonna do you make all the standards. Yeah. I'm gonna go bit upside down. Actually, I have it on the I just need to stay. Wait, I'm serious. No, I can't. A decoy.
Some of these people are.
Come here. You want cheese? Yeah. Come here. No, come back. We're taking oh my goodness.
Where's my coin? Where's our coins? Oh.
No, you're so sad. I got one. No,
We didn't do any for the review.
What's your cheese? Look at his face. He's so.
You really want a little piece, don't you? This says Daddy has spoiled you. Daddy gives you cheese and turkey in the kitchen.
Oh.
Yes, he does. Daddy can't resist the cute little.
Don't you drugs? Yeah.
You can't open the deli drawer without him giving us.
He's
Like, ooh, there's some turkey in there.
he has the cheese tax and a belly tax.
Yep, cheese tax, all the time.
His belly tax.
Look, cheese tax. Hey, y'all, Molly and check with the front door. Thank you. Come here, Oswald.
Where's food?
Come here. You sit
I think
Sit.
everyone's better.
down.
You already.
Wait.
Wait.
Leave it.
Oh,
Put it in your foot. It's on your foot.
I like that picture.
Like,
My mom just.
that combination. I think it's from
Doing
the
tricks.
time.
Quickly.
I think I did better. See that? It is. Something like that.
The poor baby.
All right, this.
Face.
That's torture. This is dog torture.
The poor thing.
Do you get it?
Yeah.
As you take.
Oh, you missed.
Get them all. Get all the pieces.
You're so cute.
There you go.
I'm gonna send this to her.
All right. Okay, we're gonna roll with or without this crew.
Danny,
Yes,
can we leave the cardboard sheet and the wood in the
you
wood?
may. Yep. Best of luck. It's gonna rain. Okay.
If I put my, can you tell them that?
Mhm.
Mine's far enough under. I think.
They're talking about leaving it in the woods.
Oh. In the wood?
Took them long enough to get it where they wanted it, so they're just gonna leave it there, I'm sure.
It's gonna rain.
Yeah, we'll see how that goes. That'll be fun. All right, I think about half of you in this room have signed up for the dance. Dance is
I got
Friday.
an actual prom dress.
Oh, did
Under
you?
$50.
It's your senior year, you should.
That was my, but it's like, I got it under 50. Everyone else I know got like 200 plus.
Yeah. Well, way to go. Last year you wore your mom's, right? It was
I
awesome.
wore her homecoming dress.
Yeah, it was awesome. It looked great. So anyway, I think most of y'all have signed up for the dance on Friday. If you haven't.
Did my mom sign me up?
I don't think you are.
Awesome.
Off the top of my head, I'm trying to remember, but I don't think you are. I'm pretty sure you guys are not. So check it because it's fun. It's fun, fun, fun. You are.
Can I give you a question?
Sure, you can just like toss it on the counter or whatever. Thanks.
The little face.
All right, so let's roll. This is going to be a lightning fast lesson. And then we're only gonna do coins for the lesson. We're not doing coins for the review because I'm gonna divide you up into teams. And we'll see how we do. All right. So I was just saying that Most of y'all, I think, have signed up for the dance. Some of you haven't. Do it, do it, do it if you can. It's always fun. It's Friday night. It's going to be about 3 hours of food and whatever music you want because Jason DJs and takes requests all night long. And it is fun. Excellent. So hopefully I will see most of you on Friday. Let's roll. This is going to be fast. And then we're going straight to review. We're going to play 4-team Jeopardy today, friends. Bye, Carlos.
Yay.
Properties of solutions. A solution consists of a homogeneous, some people will say homogeneous mixture. A solution is composed of one phase, but it can have, it is in a phase. However, it's composed of, it's not necessarily, you can have a gas dissolved in a liquid, for example, but the solution is then the liquid. So particles in a solution are not visible to the naked eye. Solution does not scatter a beam of light. Components of a solution cannot be separated using simple mechanical filtration. We will be doing some mechanical filtration next year. Yes. So what is the part of the solution that's dissolved, Yusuf? That's the solute. Very good. And what is it dissolved in, Bailey? The solvent. Very good. All right. Solute is dissolved, solvent does the solving. Here are some examples. Air is a solution. It's a gas-gas solution. You can't go through here and separate the oxygen from the carbon dioxide, can you? Not simply mechanically, no. There's gas liquid, like your carbon dioxide in your sodas. Gas solid, there's hydrogen gas and palladium metal. That's something that they do in industry. Liquid, gasoline's a good example. Solid in liquid, sugar and water, right? Liquid in solid, mercury dental amalgam, we'll come back to that in a second. And then solid, sterling silver. So sterling silver has some other metals in it, usually nickel, to help make it a little stronger. Now, mercury dental amalgam, we don't use this anymore. Why?
Mercury is toxic.
Yeah, mercury is toxic. But if you have grandparents who got fillings back when they were kids, or even your parents, potentially, there could be some mercury in there. So typically, these are now removed and replaced with new quote unquote silver amalgam. It's not actually silver, but it looks silver in your mouth, right? And sometimes composite, which is the white tooth matching stuff. Once had a dentist tell me, and this was interesting. So the composites fall apart and they get brittle and they have to be replaced every so often. And the problem with the amalgam ones is they're very brittle. They're very hard. So you think back to our simple machines and wedges. So it's like a wedge when it's filled that cavity. And every time you chomp down on it, it's like an awl that you would used to hammer wood to split it. So your teeth can crack over time. So those need to be checked. And, when you go to the dentist, they check your fillings. But this dentist told me the best thing for fillings is gold because it wears down at the same rate as the enamel of your teeth. It's inert, doesn't interact with other things, all that good stuff. All right, what were you going to say? Oh, nothing? You good? You were going to guess gold? Yeah. Problem with gold is are they gold? 5 gold, yeah, they're usually cost prohibitive, but it's a great option if you can swing it. All right, acids and bases. Acids turn blue litmus paper. What color do we know? Yeah, Bailey. Kind of like a pinkish red. Very good. And bases turn red litmus paper blue, right? Okay. So acids give off this particular ion. What ion is this? Somebody besides these two. PJ. Yeah, hydrogen ions, right? It's an H+. And bases give off this one. Does anybody know what this one is? Do you know, Caitlin? You're gonna guess? No? Jordan, do you know?
Oh, wait.
This one's hydroxide. Okay, so when you dissolve an acid in water, you're gonna get some hydrogen ions, and then when you dissolve a base in water, you're gonna get some hydroxide ions. So acids generally taste how? How do acids taste? BJ.
Acidic, sour.
Yeah, sour. All right, and how about bases? James, did you know? Yeah, bitter. Yeah, they're bitter. They're like, I don't know how often you taste bleach. I don't recommend it. Probably not something you should be doing, but yeah. It explains some things though. You've been drinking bleach?
That's the only thing they could have done like that.
So, acids will corrode what? Do we know, PJ?
Metals.
Yeah, metals, right. Okay, and then bases are going to be used to denature a certain substance. Do we know what that is? Do you know, Bailey? Yeah, what are they denatured, you know? Not in particular, do you know? Well, so proteins is what we're looking for. So that breaks the protein down into its constituent amino acid parts. So that's the purpose of denaturing. And you use bases for denaturing, which happens a fair amount in biology. Bases are also usually kind of soapy in nature. Okay, acid pH. Where is it in relation to the number 7 on the scale, James? It's lower. And then how about bases? Where are they? Ridley? Higher. There we go. All right, good. We're moving through them good and quick. All right, when you dissolve an acid or a base in water, it makes, what were we saying? Hydrogen and hydroxide, what? Yusuf? Ions. Okay, so since you have ions, it makes it more conductive. So if you dissolve an acid in water or a base in water, you're going to have a more conductive solution than just the pure distilled water itself. So they both can conduct electricity. When an acid reacts with a base, it forms a salt. Remember I told you last week when acids and bases interact, you get a gas, a salt, and water. That's typically what you get. So you can see the whole gas, obviously, like if you do the vinegar and baking soda, you can see the gas form, right? But salts are formed as well. And they can both carry and share ions. All right, now we're going to play a quick game. We're going to we're just going to vote like as a group. Milk. Who says acid? Who says base? Milk's an acid, y'all. Yes. Yes. It's gonna be below 7.
What type of milk? Cow's milk or like
Cow's milk. Yeah, but I think in general that's still like slightly acidic.
Are more basic or not?
Probably some are maybe more basic than others, you know, and it probably depends on what the cow or mammal, whatever mammal we're talking about, has consumed. But in general, they're acidic. So how about wasp venom? Who says acid? Who says base? That's a base. How about bleach? Who says acid? Bleach is a base. All right. How about mangoes? Acids. Bases? There you go. Yeah, I clicked it accidentally. Sorry. Yeah, mangoes are an acid. A lot of fruit is an acid. How about vinegar? That's an easy. Who says acid? I hope everybody says acid. All right. Lye, as in the old stuff we used to clean with. Lye. Very, very dangerous. Don't get it on your skin. An acid? How about a base? It's a base. So a concentrated acid is just as dangerous to you as a concentrated base. We always think about, oh no, somebody got dissolved in acid in this comic book. All right, you could do the same thing in a base, right? Same thing. All right, apple. Who says acid? Who says base? You got us some acid. How about spinach? Apple? I'm sorry, acid or base? Acid? How about base? Spinach is a base. Which makes sense because remember we said bases are soapy. You ever eat spinach? You get that kind of weird, sticky kind of. Yeah, there you go. That's part of that characteristic. Is what? It's an indicator. Is that what you're getting at? Yeah, the juice is an indicator.
Or could they be both?
I think it depends on the leaf itself. So how about pine? Oh, were you gonna say something?
So the people who taste the soapy instead of spinach. It's
Oh yeah, cilantro.
They have like
It's a gene you have.
Yeah.
I know it's like,
Yeah, it's a genetic predisposition to eat cilantro and taste soap. Who tastes soap when they eat cilantro? Anybody? Oh yeah. Sorry, that's unfortunate. It's very tasty to the rest of us. All right, how about pineapple? Acid or base? Acid. Okay, base. It's an acid. Yeah. All right, and how about? Come on, I clicked you. There you go. How about soda? Acid. Base. Totally an acid. Remember, it has carbonic acid in it. All right, hand soap. Acid. Base. Yeah, you got it. How about lime? This is like the lime that you would eat a lime.
lime fruit. Okay.
Okay, what are we saying? Acid? Yeah, base. There you go. Baking soda. That should be easy. Acid? No. Base? We know that one, right? Window cleaner. This is like Windex, this kind of thing. Acid? Base? Yeah, it's going to be a base. Now think about this though. A lot of people use vinegar, make their own homemade window cleaner. I do that. And that's an acid. So obviously you can clean with either. All right, stomach juice. This one you should know. Acid? Yeah, it's an acid. What kind of acid is it? It is hydrochloric acid in particular. You two don't do any of the chitty chatty back and forth today because we need to focus and whip through this and move on to review. All right, drain cleaner. This is like Drano, the stuff you pour down to get the hair clogs out of the drain. Is this going to be an acid or a base? Acid? It's a base. Yeah, it's actually a base. It's usually sodium hydroxide. And it's pretty concentrated. You don't want to get that on you either. All right, so universal indicator. In particular, the most common one is kind of like a brown orange color, and you can drip it into a solution and it will change color based on the pH of the solution. And it's a scale that looks very much like this. It's not the only indicator. We have like phenolphthalein, bromothymol blue, methyl orange. We'll use all three of those next year in lab, as well as universal indicators. So there are ways to tell. Anybody have a pool? Do that thing where you scoop the water out of the pool and you drip stuff in it and watch the color to see if your water is too basic or too acidic, whether or not you need to condition it. Yep, same concept. All right, so now we're moving on. Are we ready? Okay, give me 1 second to move this out of the way and switch the screen. Whoop. And now we're going to divide you into teams. So we're going to go for 4 teams here. So let's do 1 team at the table. 1, 2. Let's put Liam, will you be with this group here? Okay.
Sure.
Lucas with these 3, and then Bailey and Emily with Asher and Drew. Okay. So if you want to move, you can move. If you don't want to move, you don't have to move. Let's decide how your team amongst yourselves for a minute. Decide how your team is going to answer. Are you going to have one spokesperson answer for the team? Are you going to take turns answering questions and then that person gives the answer? So
Which team,
You're over here with me.
you're with Emily and Bailey. So we have Emily, Bailey, Drew and Asher, Ridley, PJ, Caitlin, Lucas, Liam. Where are we? Oh, Liam, Jordan. Yes, Liam, Jordan, Xander, and Yusuf, and then Milo, Colin, Chloe, and James. So decide how you're going to answer. No, it's all, we got 4 teams. It's all sorted.
You might want to do this next to having answers. Because you must, if you don't, you're just gonna go.
You can put your chair back if you want to or whatever. I said you can scoot your chair back or whatever if you want to. It doesn't matter. Wherever you are, you're comfortable, you're fine. Or you guys can pull some chairs up. Those 2 chairs from over there. You can get a chair from over there. You good? All right, so we're just gonna go in order. We're gonna go this team, back team, this. So this is team 1, 2. No, yes, I'm sorry. 1, 2, 3, and 4. Okay. Everybody know how they're answering? Okay, if you get it wrong, you get it wrong, you lose the points. We're not gonna shoot it up to another team. We can shoot, if we have time to play twice, we'll shoot it up to another team. Caitlin, question.
Are we going to?
Hang on, wait a minute. Caitlin's trying to, Caitlin's trying to ask a question. Yes.
Are we going to be picky about what is?
Yes. You have to answer in the form of a question.
What is?
Are we ready? Do you have a question, Lucas?
Play Jeopardy music.
No. I might hum it if you're taking a long time answering. So this first time through, if you get it wrong, you get it wrong, we move on. If we have time to play a second round, if you get it wrong, we'll leave the question on the board for the next team to choose. Okay, team number 1, are we ready?
Yes.
Where are we going?
Let's just name that scientist.
Name that scientist
Very
for
bottom, very bottom. Yeah.
1100. Name that scientist for 1100. The frog guy's nephew. This man was responsible for reanimating a human corpse.
It's Giovanni. Who is Giovanni Aldini?
Very good. Giovanni Aldini is the correct answer. You are gonna want to know inside and out one of the 2 great science smackdowns from Q3. So that's the Volta and Galvani one, which involved this Aldini guy. And then the other one is Edison and Tesla. Very good. All right. So Team 2, where are we going?
Yeah.
For 1100. Work, 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 work. In order to do work on an object, force must act in the blank of motion. What is the direction? Very good. Excellent. And team number 3, where are we going?
It's electric for 1100.
It's electric, 1100. Electric and magnetic fields are oriented thusly to one another. Ooh.
What is perpendicular?
What is perpendicular? Very good. That one's a little tricky if you're not quite sure what's being asked. Very good. Yes, right hand rule. Good job, Bailey.
1100.
Catch a wave, 1100.
What?
This phenomenon, wait a minute, let me ask it because the review is for everybody, not just you. This phenomenon is essential in the function of fiber optic telecom cables.
What is total?
What is total internal reflection? Right, Jason? That's his livelihood back there. He's like, yeah. All right, team number 1, we're back to you.
Science matters for 1100.
Science matters for 1100. When atoms lose or gain an electron, they become one of these positive or negatively charged particles.
What is an ion?
Very good. You got it.
Are-
What are ions? What is an ion? I'll accept it. It's all good. Able to, team 2. I like to move it, 1100. These are the 4 laws of thermodynamics. Okay.
Isn't he dead? Yeah.
All right. They can help you. Your team can help you.
So, do we have to do them in order, or as long as we can name which one they are?
You're gonna have to on the exam, you're gonna have to label them. It's matching. So you need to know which one is 1, 2, 3, and 0. Yes. Getting there.
Yes,
Okay. That's the second one. You got it. So we're only missing 1. It's the one I asked outside and everybody's like, huh? And I said, what if that wasn't? You got it. You've got it. Energy is conserved. So first, energy is conserved. Second, energy can flow from colder objects to hotter objects only if work is done on the system. Third, which means that it's going to naturally flow from hot to cold, right? Third, absolute 0 cannot be reached. And 0th, our favorite, if 2 thermodynamic systems are in thermal equilibrium with a third one, then they are in thermal equilibrium with each other. Outstanding. Yes, ma'am.
Do the A equals C, B equals C. and
Yeah.
A equals C.
Yeah, but it's matching, so you won't even need to.
great.
All right, team number 3.
Name that scientist 1000.
Name that scientist for 1000. Eureka! Legend says he ran naked through the streets out of excitement over his newfound ability to determine the volume of an irregularly shaped solid. Who is Archimedes? Outstanding. Very good. Team number 4.
For fun. It's I like to move. Work.
Which number? Work, 4. 1000. All righty. This is the value of G, the gravitational constant for free fall on Earth.
What is 9.8 meters per second squared?
There you go. 9.8 meters per second squared. All righty.
No.
Wait, what's it?
He has like those rad.
Yeah.
Yeah.
Yes.
Okay.
That's great. Very good. Science matters for 1000. This may occur when thermal energy is absorbed. Okay, now there's lots of things that may occur, but this is the one that I read outside. So think about it.
What is a phase change?
You got it. Very good. What's a phase change? Now there is a phase change amongst your listen, there's a phase change, a specific phase change listed amongst your multiple choices for this question. And it cannot be the answer because it's the wrong phase change. Does everybody hear that? Some of you were talking. So listen, this is a multiple choice question. There is a phase change listed as one of the choices, but it can't be the correct answer because it's the wrong phase change. Okay, so a phase change is your best answer. All right, team 2, slick sunglasses, where are we going? Surfs up, 1,000, catch a wave. The proportional relationship between wavelength and frequency is this. There you go, inversely proportional or inverse. Outstanding. Team number 3.
I like to move it for 1,000.
I like to move it for 1,000. When the force of air resistance and the force of gravity equalize, a falling object's velocity stops increasing. The object will fall at a constant velocity known as this.
What is free fall?
What is free fall? You got it. Outstanding. Team number 4. The only 1,000 left. It's electric. These are often used as semiconductors.
Or metalloid, or what is a metalloid?
Yes. Okay. Be sure you're giving your team a chance to consult and answer because they need the review as much as anybody else needs the review. So if you're spitting them out, nobody else gets a chance to review. Yes.
Wasn't that last one terminal velocity?
No, it's not orthogonal.
Free fall. Your terminal velocity. Where is
The
this?
speed at which it.
Where was the question? 1,000.
Yeah, I know which one it was.
It could be terminal velocity. I suppose that may be a better definition.
I'm just gonna let you know there are duplicates for like 3 questions.
Yeah, I saw that afterwards. It's so hard when you're doing it because it's like you don't see the question until when you're editing it. It's hard, but that's okay. Those are just ones you really know well. All right, team 1.
Name that scientist for 900.
Name that scientist for 900. This dude hung frog legs on his fence as part of his bioelectricity experiments.
Who is Luigi Galvani?
You got it. Who is Luigi Galvani, or was, because he is very dead at this point in time. Team number 2, where are we going? 900. When discussing the work done on a lever, the load may also be identified by this term. What is the effort? Very, very good. Outstanding. Team 3, where are we going?
It's electric for 900.
It's electric, 900. In this force, opposite poles attract and like poles repel.
What is magnetic force?
What is magnetic force? You got it. Team 4.
Do something. 500.
Somebody pick. Jordan, you pick.
I like to move it 900.
I like to move it 900 now. Discuss before the answer is spat out. Make sure everybody gets a chance. Okay, this is the force that opposes the motion of objects that touch as they move past each other. Everybody agrees. We got friction. Very good. All right, moving on. Team number 1, where are we going? Where are we going, team 1?
Oh, science matters for 900.
Science matters for 900. In an experiment, this is what you change.
What is an independent or manipulated variable?
Perfect answer. What is an independent or manipulated variable? Team, what's up?
Oh, so do I have to write what, so if it asks what in the experiment, what is changed, do I have to write independent or manipulated variable?
You can write either.
Okay.
Either or both. Team 2, what's up? Surfs up 900. Catch a wave. The frequency of a sound wave. That's amazing. That's amazing. That so does not work for you, but all right. What is pitch, says James, and he is right. What is pitch? Yeah. All right, what's up, team 3?
Name that scientist for 800.
Name that scientist. 800. The unit for measuring electric potential is named for this Italian.
14 Volta. Alessandro Volta.
Who
Who is?
is Alessandro Volta? Yeah, you get it. All right, excellent. Team 4, where are we going?
Science matters 800.
Science matters. 800. 200 grams is equal to this many kilograms.
Let them think, Yusuf, not give them the answer.
Yep.
So 0.2. What is 0.2 kilograms?
0.2 kilograms or 0.2. Yep, correct. Excellent. Team one, where are we going?
What?
Science matters?
No, we already
No?
did that one.
Well, that was taken.
Work for 800.
Work, 800. Okay. Its rate is power and its SI unit is the joule.
What is work?
There you go. Very good. Excellent. What is work? All right. Where are we going, James?
I took your word for it.
It's,
Surf's up. Catch a wave. 800? 800. The wavelength of a light wave determines this in our perception.
what is, color?
There you go. What is color? Excellent. All right. Team three, where are we headed?
It's electric for 800.
It's electric, 800. If you're walking around in socks and you get zapped by a doorknob, you've experienced this.
What is electric discharge?
Can you be more specific with your answer?
Static.
What is static?
What is static discharge? You got it. Excellent. Team four.
The only 800.
The only 800 left. I like to move it, move it. A push or a pull on an object is measured in this unit.
What is a Newton?
What is a Newton? Because a push or a pull is a what? Force. Outstanding. Team one.
Name that scientist. Yes. Name that scientist for 700.
For 700. This Serbian-born scientist championed AC power.
That would be, who is Nikola Tesla?
Who is Nikola Tesla?
Edison's DC.
There you go. All right, team two. 700. This is the ability to do work. What is energy? Yes, sir. Very good. All right. Oop, it didn't go. Go. There it goes. Team three.
Oh, no.
Yeah.
We all are all like waiting.
It's electric for 700.
It's electric for 700. This is the process of transferring charges between objects that touch.
What is conduction?
What is conduction is correct. Very good. All right. Team four.
Surf's up, catch a wave 700.
Surf's up. Catch a wave. 700. When combined in equal amounts, red, green, and blue light will produce this.
What is white light?
What is white light? Very good. Very good. I think that one's one of your duplicated ones. So when we get to it, we'll just skip it and move on. All right. Team number one. Yeah.
It's 400.
Is it 4?
It's
Okay. We'll do that and get it off the board. All right. Where are we headed?
Science matters 700.
Science matters. 700. This is the formula for density.
Density is mass. Okay, what is mass over volume?
There you go. Mass divided by volume, mass over volume. Very good. Okay, team two, where are we heading? I'd like to move it for 700. This is the ratio of the distance an object moves to the amount of time in which the object moves. What is speed? Very good. Excellent. Team number three.
Name that scientist for 600.
Name that scientist. 600. He developed the first periodic table.
Who is Mendeleev?
There you go. Who is Dmitri Mendeleev? Very good. Very, very good.
Who was? Not
Yeah, who was? Who was, because he's dead. Yep. All right. What's up over there on the couch? Team four.
And he created it. Like, it's electric.
It's electric. 600. These are often used as semiconductors.
Yeah, that's another.
We had this one already, so we will skip it and pick another one.
No, work 600.
Work, 600. This is the number of times a force exerted on a machine is multiplied by that machine.
What is mechanical advantage?
There you go. He pulled it out of the depths there. What is mechanical advantage? All right, team one.
No one to go. Do you have the points?
Yeah.
Science matters 600.
Science matters for 600. Where is it? There it is. Oh, not that. Hang on. There. In a closed system or reaction, matter like mass is always
What is constant? Conserve, whichever word you're looking for.
What is conserved? That's what we're looking for. All right, team two.
What's the word you're looking for?
Yeah.
Surf's up, catch a wave. This is thermal energy moving from a cooler object to a warmer object. What are we going for? Yeah, but yeah, what is?
What is the answer?
Nothing.
We gotta see what's correct answer.
You got an answer? Cooler to warmer. Yeah. So we're looking for heat moving from, actually, it should be, oh, I think it's written backwards.
Yeah, it's backwards.
Oh, I'm gonna edit that. So yeah, I'll give you that because your answer was, that was just confusing, but I'm going to fix that when it should say cool. Should say warmer to cooler. I'll edit that to make it correct. All right. Team three.
I like to move it for 600.
I like to move it for 600. This is the force that acts between any two masses.
What is gravity?
What is gravity? Easy peasy. Excellent. Team four.
Work.
Right, yeah.
Work. 500. The 6 types of simple machines.
Okay. What are screw, pulley, wedge, wheel and axle, inclined plane, and
Wait, no, what did we already say?
Screw, pulley, wheel and axle, inclined plane,
a wedge?
wedge,
Lever.
lever. Very good. Which two are arguably modified inclined planes?
Yeah, a screw, a wedge.
Screw and a wedge. Very good. Excellent. All right. Moving on. What's next?
Name that scientist for 500.
Name that scientist for 500. His name represents the unit for pressure.
Who is, it's Pascal, isn't it?
Pascal. Yep. Who's Pascal?
What's his first name?
Blaze.
Blaze.
Blaise Pascal, okay.
Yep.
Pascal.
Team 2. What?
Oh,
Is what?
Fully also be considered a modified.
No, not really.
Yeah.
Catch a wave for 500. Uh-oh, are we listening? Okay, what is this creating? What is this showing? Yes, what is destructive interference? Very good. If you see that, that's destructive interference, right? All right, team number, where are we? 3.
It's electric for 500.
It's electric for 500. Computer information is represented in this type of system, which contains only 2 digits.
What is binary?
What is binary? Very good. That's your answer. Team 4. We'll take your pick.
Science matters.
Science matters. 500. Matter will change from one state to another if this type of energy is absorbed or released.
What is thermal energy?
What is thermal energy? Very good. Very good. Team
The 500.
1, 500. These are Newton's 3 laws of motion.
So the first law is an object in motion or object at rest will stay at
Mhm.
the perspective until acted upon by an outside force.
Yep.
You want to tell me answer number 2?
What's the second one?
A equals F over M.
Okay, or F equals ma. Yep.
And then number 3 is for every action, there's an opposite and equal reaction.
There you go. So you got inertia, which is the first law. An object in motion tends to stay in motion. Object at rest tends to stay at rest unless acted on by an outside force. There should be a parentheses there. F equals ma is the more force, the more acceleration, and then action reaction. Yes.
So can I technically write for the first law, can I write inertia, then the second law, F equals ma?
Yes. And you can write action reaction. You
The-
can do it just like that.
The question.
Team number 2. What's up?
You didn't add the point.
We just like to hear him say it.
No, I did.
I did. All right,
Yeah.
work, 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 work. Work over time is this. Yeah, it is knowledge. What else is it? Knowledge is what?
And
I'll say it. My bad. Work.
Knowledge is. There you go. Knowledge is power. That's the whole point. Oh yeah. Oh yeah. Oh, you should have said what is. We gotta watch the what is. Oh, did he say what is? Oh, I couldn't hear you. All right, team 3. Yeah, I know. Team 3.
name that scientist for 400.
Name that scientist for 400. His principle explains the concept of lift. Bless you. Who is Bernoulli is correct. Daniel. It's exciting. Yeah. He doesn't get one of the big fancy names. He's just Daniel. All right, team 4.
Be different. Stand out there.
Team 4.
That's you, yeah.
Let's see. I want it's electric 400.
It's electric for 400. All right. When a current carrying wire is placed in a magnetic field, electrical energy is converted into this type of energy.
What is electromagnetic?
What is kinetic energy?
Yeah, kinetic is what we want right there. Okay. Everybody pay attention to this question. Now, I told you that you're going to have a lab practical, and you're going to have as one of your bonuses, and then you're also going to have some other open-ended questions that are kind of coming at you, like, well, you know, to study for the science smackdowns. But I need you to keep this one in mind in particular, because you may be asked to witness a particular phenomenon, part of which is hidden. But you're going to know what's hidden because you understand what this means. Okay? And if you're asked to describe something in detail, describe it in detail. Okay? Okay. What's up? 1.
Where do y'all want to go?
Science.
Science matters 400.
Science matters 400. An educated guess or explanation that is either repeatable and supported or repeatable and rejected.
What is a hypothesis?
What is a hypothesis? Is correct. Is it either proven or unproven?
Nope.
No, it's accepted or rejected, and not proven or unproven. All right.
Could you say supported and rejected?
You could say supported and rejected. Yep.
No, accepted or rejected.
Yeah, supported's better. Okay, I like to move it 400. Mass times acceleration. What is force? That girl. You got it. Because F equals ma. Team 3.
Name that scientist for 300.
Name that scientist for 300. This man was known as the Wizard of Menlo Park. Who is Thomas Edison? Is correct. Good old Tommy. All right, team 4.
Work 300.
Work 300. A joule is equal to this. Oh. Joule's the unit for what? Yeah, it's the unit for work. So what is work? What's the formula? Do we know? Oh. Do 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 do.
So what do you want from me? Like,
What do you want? Danny, your answer is a Newton meter. Newton
Deducted?
meter. Yeah, you get it wrong, you get deducted, or you don't get it, you get deducted. Team 1.
Where do y'all want to go?
Science matters.
Science matters for 300.
Science matters for 300. It's important in a controlled experiment to conduct a controlled experiment in which only this variable is deliberately changed.
What is a independent or manipulated variable?
There you go. And what's the one you're keeping the same?
Control.
Yep. And what's the other one?
Dependent.
There you go.
Just the other one.
The other ones, all the other ones. Yes, ma'am. Was it? No, it's actually it's phrased differently, I think. Yeah. Same answer, but it's phrased differently. No, you're good. You're good. That's good. All right.
Another question for more points.
Team 2, where are you going? Surf's up, 300. This type of wave is well above the range of human hearing.
That is terrifying.
What was that?
That's kind of in my
Milo. What is Milo?
You got it.
It's better than.
W.
There's no question mark after ultrasound, so there's a
Oh. All right, team 3.
What? It's electric for 300.
It's electric for 300.
What?
This type of circuit, the kind often used in strings of Christmas lights, has only one path through which a current may travel.
What is a series circuit?
What is a series circuit? Outstanding, very good. Moving on, team 4. The only 300 left. Who is texting me? Is it an emergency? Oh, hey, somebody left the gate open. No, but we heard Ozzy, so he's up here somewhere. No, I believe my mom has closed it, but you guys have to remember to close that gate. Close that gate. All right, you're going for this one?
Yeah.
Move it, 300. Who's up? Is it team 1? Team 4? Is that where you're going? Okay. Tendency of an object to resist change in its motion. What is this?
What is inertia?
There you go. What is inertia? Very good. Outstanding. Team 1.
Name that scientist?
Yeah.
For 200.
Name that scientist for 200. Because of his discoveries, we know the universe is expanding.
Who was Hubble or who was Hubble?
Yeah, there you go. Hubble. Outstanding. Edwin. All right. Where are we going, team 2? Work. 200. Forces acting in this way are added together. In the same direction. Very good. Everybody's taking their spin on these.
They're just playing past the glasses.
Where are we going, PJ? Surf's up, catch a wave, 200. Objects that reflect light are illuminated. Objects that emit light are?
What is luminous?
What is luminous? You got it. Very good. Team 4.
Science matters 200.
Science matters for 200. Gravity works against this force.
What is lift?
Ooh,
What is buoyancy?
I'll take your second answer before we make a guess. Yes, what is buoyancy is the answer we want. Very good. Oop. Click. Hello. Click. There you go. Although technically, yeah, kind of would work against lift, but buoyancy is what we're looking for.
Because we missed one question
And they went first. Yeah.
It's electric for 200.
It's electric for 200. We're going to scramble the team second time around. Electrons carry this kind of charge. What kind of charge?
I'm trying not to answer.
We're conferring. Asher has an answer.
What is a negative?
Negative charge. You got it. Team 2. I like to move it for 200. The rate at which velocity changes.
Yeah.
What is acceleration? Very good. Team 3, where are we going now?
Name that scientist for 100.
Name that scientist. 100.
It's our.
Yeah.
Prior to his death and burial at Westminster Abbey, this English scientist was knighted by Queen Anne in 1705. How moving.
So Isaac Newton.
Who is Sir Isaac Newton? Outstanding.
Was
And yeah, who was? Team 4.
Surf's up, catch a wave 1.
Surf's up, catch a wave, 100. Light travels as both a wave and as these particles.
What are photons?
What are photons? Now, remember how I read that question to you outside?
no.
It's not a wave of photons. It's a wave and photons, right? Read carefully. Did I give you credit? I don't think I did. There you go.
Where do
Okay.
you want to go? What? Science matters 100.
Science matters 100. An organized plan for gathering, obtaining, and organizing information. You got
What is
it.
the scientific method?
What is scientific method? Boom for an even.
Nice.
Nice round number. All right.
Yeah.
Work for 100. Pascal's principle is at work in these systems. What are hydraulic systems? Very good. Team. Oh, wait, it did it. Team 3.
It's electric for 100.
It's electric for 100. Device that uses an electric current to turn an axle.
What is an electric motor?
That's very good. An electric motor is your answer. And team 4, the last one on the board. The speed and direction in which an object is moving.
What is the law?
What is velocity? Velocity is a what?
Vector and
It's a vector.
yeah.
It's a vector. Yeah. Oh, yeah. Okay. Very good. Very good. All right. Now let's do slides. Credit goes to Bailey. So let's do it like this.
You carry it. Yeah.
We'll do 2 teams for slides. You 2 are with the back table. So I have the front of the room and I have the back of the room. So I've got what, 6 back there? 1, 2, 3, 4, 5, 6. I need,
So good.
here, let's do Emily. Hang on. 1, 2, 3. They do.
Can you go put it down?
Yeah. Lucas and Emily, you go to that team too. So then we'll have 1, 2, 3, 4, 5, 6, 7, 8, 9. And 1, 2, 3, 4. Oh no, do I only need 1 more? No, I need 2 more. Okay, I can take your binder. How many do I have up here? Put moving. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5. You have 6, 7, 8. So yeah, you got it. There you go. Okay.
No. Why?
What happened? Oh man.
That's all true.
W black.
That is not
so good.
attractive.
Drew, you look so good.
Those little sunglasses were mine when I was 3 and James wanted them.
So he stole them.
And the case that they were in.
1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, 1 more.
You got one of them.
Wait, I'm gonna do this. Chloe, you come up here,
Yes.
and then Jordan and Liam, you go back there. Now we have a predominantly girlish team and a predominantly guyish team, and then y'all get to hang with the others. All right, let's do this.
All for this fresh.
No, Yusuf, staying here.
Let's go in the morning. Do it better or not.
Swapping them out, swapping them out.
Those 2 off.
No, they're good. We'll leave them. Unless you want to go complete girl against boy. Do you want to do that? Oh, they want to do that. Squished in the middle.
Yeah, let's do it.
There we go. I love it. Hey, dudes in the back, would you rather outnumber the crew in the front by taking these 2? All right, go back there. Let's see. We'll give it a shot. We'll give it a shot. All right. This is great. I love it. All right, so we'll start with team in the front. So we'll do front team, back team. Front team. Yes. I didn't set it up this time. I wanted to, I just ran out of time. That's so fun. I'm trying to set it up for your fall midterm next year though. And organize, yeah, I've got the one from midterms, but it misses all the questions for finals that aren't. Oh, you have flashcards. Okay. Well, let's roll through these. So, team in the front, an organized plan for gathering, obtaining, and organizing information is. All right. Yeah, you can answer them as a no. Just answer them as a group. Hey, hey guys, I don't want to yell. So, all right. Scientific law
What happens? A fact.
and scientific theory.
Why happens? Explanation.
Great. Team in the front, give me all three. Why is science not settled?
So it assumes science exists in a binary state, which it
One.
doesn't.
Yep.
Assumes a four are good in one, and it makes a four good in another.
Yep.
And then natural science isn't about 100% proofs; it's about inherent uncertainty.
She got all three. That's perfect. That's what you need. Keep the volume down so everybody can hear the answers because the review's for everybody. Okay. Dudes in the back. An observation is made using what? The senses, and an inference is made based on?
Prior knowledge and experience.
Okay, I can hear you. You don't need to yell. All right, very good. All right, law of conservation of energy, crew in the front.
Energy cannot be created nor destroyed; it just changes form.
Excellent. Guys in the back. Law of conservation of momentum. Wait, one person say it. Wait a minute. No. Somebody say it. What's the answer? So it's if no net force acts on a system, the total momentum of the system does not change. All right, Newton's first, second, and third laws, group in the front.
You can answer. You want to do the third one? Okay.
Yep.
So an object in motion or an object in rest will
Hang on a second. Guys in the back, if you're not listening, you're not getting the review.
by
Yep.
an force, F equals ma is the second one. The third one,
Every action has an equal and opposite reaction.
Very good. Excellent. Y'all be sure you're listening because these answers are what you need to hear. All right, guys in the back, what's Pascal's principle? I've got real quiet. Hang on, you're getting an answer over here. Hold on. Asher's answering. Say it again.
Pressure is equal to
That's pretty good. Anybody want to add to it?
As the speed of the fluid increases, the pressure.
You need Pascal. So it's a change in pressure at any point in the fluid is transmitted equally in all directions and unchanged. All right, in the front, Bernoulli's principle.
as the speed of the fluid increases, so does the pressure, or vice versa. Pressure
Within the fluid.
Yes, okay. As speed of a fluid increases, the pressure within the fluid decreases. Pascal's principle in the back, is it work in what systems? Hydraulic. Look at them, they're missing review. That was a question, just went by so fast. Whoopsie. Oh no, how did that just happen? No, do not annotate. Thank you. Go to the next slide. All right, in the front, Bernoulli's principle helps explain the concept of lift. No. What is, guys in the back, what is described as a force distributed over an area? In the back, pressure. And the unit for measuring it is what? Pascal, there he is. Remember little Blaze? Oh, little Blaze Pascal, so cute. All right, in the front, a push or a pull on an object is a
force.
A force, and a force is measured in newtons. Very good. In the back, the force that opposes the motion of objects that touch as they move past each other is friction. In the front, what's the force that acts between any two masses? Gravity. In the back, the speed and direction, in which an object moving is it? Yes. Should say object is moving. It's not there. Ratio in the front. Ratio of the distance an object moves to the amount of time the object moves is its speed. All right. What is, guys in the back, what is the rate at which velocity changes? Acceleration. Let the whole question be read. Let the answer be said so that everybody can hear it. It's not a speed challenge, it's to make sure everybody hears it. Okay, in the front, when you're riding a Ferris wheel, What are you guaranteed to experience? Not your team. So ladies, yes, your answer was. There you go. Yep. You're gonna get these options. Obviously, you could experience total boredom or buoyancy, or if you get dropped off, you could, but you're definitely gonna experience acceleration. Okay, yeah. What now?
You got a nosebleed, wouldn't that be buoyancy?
A nosebleed. How's a nosebleed buoyancy?
That's considered a full of buoyancy.
I don't think so. All right, at the back, it takes a lot of hard work for who? Yes, hard work. Sorry, I said the answer for you. And what's the second part? I wonder what Watson had to do to become the most. So this means that a joule is the unit for, and a watt is the measure, the unit for power. Yes. All right. In the front, what's the ability to do work? Yes. And what is the transfer of energy in the front? There you go. Very good. In the back, light travels as a blank and also as particles called blank. Travels as a wave and also as particles called photons. Very good. In the front, when combined in equal amounts, red, green, and blue light will produce. Why is it not red, blue, and yellow?
Because that's colors of
That's the primary colors for color. not
For
color.
yeah, for
Not red,
pigment.
black.
Yeah,
And
for
it's seven
pigment.
things.
Yes,
I said
red, yellow, and blue are your pigment primaries and they produce black. Red, green, and blue are your light primaries and they produce white. In the back, what's above the range of human hearing?
Ultrasound.
Give everybody a chance to answer back there. All right, in the front. In the front, the distance from crest to crest or trough to trough. Wavelength, and it gives you the perception of
Do you want us to
color.
answer all of these? The second one as well, the back one.
Hang on. So we'll do the back at first. Okay, back group. Number of times the same part of a wave passes a fixed point within a given time period is, and it gives you your perception of pitch. Okay, in the front. The answer is already here, but can somebody kind of explain why salt water is better, Bailey?
So water actually doesn't conduct electricity. Ions give water the salt. The ions in the salt give water the ability to conduct electricity.
Right.
Or yeah, it's electricity.
That's what you need. Yes.
So that, when storm comes and then the poles that carry electricity fall down, why do people tell you not to step on the water?
The wires, because they're live.
And it doesn't go down, it comes up. Kind of.
You're talking about the electrical wires? There's still electricity running through those wires. They're live. Yeah.
That doesn't mean they're conducting electricity. Why?
They still are.
Yes, because they're insulated, but they're conducting electricity inside them. But still, there's arcing and stuff that occurs around them, and yeah,
If it tears open, you still have open wire.
yeah. Mm-hmm.
Why would, if you have to touch a wire, touch it with the back of your hand, because if it is live, it will cause your hand to close. and
Yeah.
you physically cannot let go.
That's true. It'll cause, those muscles are all controlled by electrical impulses, and you will be gripping. That's why they say if a person is being electrocuted and they're frozen because they're being electrocuted, do you pull them or push them? You push them, because pulling them requires you to grab, and now you're attached too. You push them, right? Now, there was that video that came out in the fall, I think it was, of that kid that was down in the road, laying in the road. There were live wires all around him, and he was being electrocuted while laying in the road. There was no way to push him. So the guys had to go in there and they were pulling him off, which meant it was conducting right through them too. It was insane to watch.
They could have used rubber gloves.
They could have, but they weren't going to spend the time to go get him. So they had to just grab him because it was desperate. All right, team in the back. Give me one or the other smackdown with as many details as possible. And then you guys in the front are gonna tell me which one you're using. Which one are you gonna do? They're gonna do Edison Tesla. So you guys in the front work on your story for Galvani and Volta. Be sure you have as many details. I'll give you a minute.
So these two guys, Edison and Tesla.
Uh-huh.
Edison-
Wait a minute. Shh. Let James talk.
Just say their last name.
Yeah, it's fine. You're good. Go ahead.
Edison and Tesla. Edison is like wow, DC is so cool because I made this light bulb with it. And Tesla is like, no, AC is way better because there's so many more applications you can do with it.
Mm-hmm,
Like, long distance communication works better with it,
mm-hmm,
other things like that.
yeah,
And then they go back and forth, they try proving each other wrong. Edison uses alternating current to execute elephant to show that it's too dangerous to use in the homes. And Edison, he's selling a lot more of his products,
mm-hmm,
instead of keeping them to himself,
mm-hmm.
while Tesla is keeping. I'm not sure if he's making patents, but he's keeping all the ideas for himself.
Yes, Edison marketed his ideas, right, for profit, whereas Tesla would have given them away, but he was just kind of keeping them to himself, but he was willing to give them away.
And then the SmackDown ends with Edison.
Losing?
Losing.
But also, here.
Do what? Oh, yes, he was accused. Yes, there was a conspiracy that he was accused of down Tesla's lab, but we don't really know if he did it. All right, in the front. Yeah, he's accused.
A lot of theory.
Well,
Dang,
it's a conspiracy. It's an accusation. We don't know if he actually did it. All right, in the front. We're doing Volta and Galvani.
So Galvani was experimenting and he figured out that he could move frog legs with electricity. So then he started calling it bioelectricity because he thought that there was something with the frog legs in the electricity that was making them move, which he was kind of right, but not really right because it wasn't using things. So then he stuck frog legs on his metal fence in a lightning storm, and his neighbors probably thought he was crazy. And he started telling people, and Volta decided that he was wrong because he didn't believe him and was trying to prove him wrong by making a battery, which then backfired because then Giovanni's nephew, Giovanni, ended up using that to reanimate humans, and
You got it.
so
That's pretty much it,
he
yeah.
used a guy that was hung for allegedly killing his family, and he completely sat up and
Got it.
opened his eyes.
You got it. Very good. Very good. All right, those were great summaries. Either of those will get you your full value of extra credit points for that question. Okay, really good. You have to write as much as you can. If you get to it, if you're somebody who has a writing issue, and some of you do have writing issues or concerns with writing, and you're getting to the point where you're like, I can't write any more of this. If you want to come over to me quietly and say, this is a long one, may I dictate my answer to you? Can you go look for him, please? I don't know where he is, but he's stuck somewhere, like in a bathroom or a closet or something stupid. So anyway, if you want to do that, you may come over to me and I will, but I'm going to write whatever it is you're saying. And I'm not going to tell you if you're right or wrong. Okay. I'm just going to write whatever you're saying. All right. So back to the back. The process of transferring charges between objects that touch is what? Very good. In the front, what kind of circuit has only one path through which a charge may flow? And what's the one where it has more than one path? Parallel.
Question.
Yes.
Are we gonna have to label working light bulbs like we did?
Yes.
Yeah, that was pretty easy.
In the back, with what? Opposite poles attract and like poles repel?
Magnetic force.
Magnetic force is very good. Magnetic force. All right, who's the student in the front?
Dmitry Mendeleev.
Yeah, it's Angry Santa, Dmitry Mendeleev. Merry Christmas. Here's a periodic table. Yay. In the back, what can occur when thermal energy is absorbed or released? Hold on.
A chemical reaction.
A phase change.
A phase change. Very good. Can you look at the front door, maybe? They shouldn't be, but since the gate was open. Do you see him? Okay, well, I heard him, so he's definitely somewhere.
I think, is he stuck somewhere?
No, he sounded like it was coming from that. This house is so impossible to hear, like, you can't tell where sound is coming from. Somebody will be in one room and they'll be like, hey, where are you? Where are you? We're like, it bounces. It's weird. Acoustics in here. Okay, front. Boiling and evaporation are both types of.
Vaporization.
Very good. In the back, a color change is a clue that what's taking place? Chemical reaction. Be able to give a clear example of each of the following. I suggest you go back and look at your lab. Getting tricky with Newton's laws, huh?
Trapped himself behind the wires.
Oh, in the pub? Your speaker, daddy's speaker wires?
Yeah.
Is he alive? Can you get him out?
Oh, question.
Dummy.
Have to use the ones from the Get Tricky Lab? or
You
use-
do not have to use the ones with the Get Tricky lab, but that's an easy one because they were very simple. What you have to watch for is this. If you say, Newton's first law can be observed in a car accident, I'm going to barely give you credit for that. You need to tell me in what part and how. So you could say Newton's first law, an object in motion tends to stay in motion, an object at rest tends to stay at rest unless acted upon by an outside force, can be observed in an automobile accident when a car that is moving at a constant rate suddenly stops moving and the passenger inside continues to move forward until restrained by the seatbelt. That's Newton's first law.
By the windshield, if they're not there in the seat.
Yes. Did you have a question, Liam?
It says be able to give a.
Yeah, somebody already found that one. Yeah, but you're right. Yep. And so be sure that these are really clear, not overly complex. Okay. Keep your life simple. All right. These circuit diagrams, we did this. Remember, I handed them out as little worksheets. Be able to do one of those. This is the same. This guy's the same guy. This dude's in everything we do, right? This one here with the variables, he's always there. And this one is always there. We know these, right? This one here, if you put load instead of effort, that's fine. But I do need you to show that it's force, output, input, fulcrum. Yes, sir.
What happened to Rico at the my mind still that?
Good boy. I don't know. I keep forgetting to put it on there.
Graded for eternity.
Yeah, I forget engraved for eternity all the time. I just forget it.
Engraved
These
in
are
for eternity.
examples of triangles you may want to put on your index card. What's this one?
Distance over speed or velocity and time.
Yes. What's this one?
Voltage over current and resistance.
Yes. What's this one?
That
That's
one's
it.
spelled.
Velocity, acceleration, time, force.
Over mass and acceleration.
There's this one.
Work over force. and-
Force over distance. Remember, work is a Newton meter, right?
Yes.
Newton meter, there's force over distance.
Which means force is the Newton and distance is.
Very good. There's the one.
Isn't that
Work,
work over power?
power,
time?
time. Power equals work divided by time, right? Mass, density, volume. So if I asked you how to find density, it's mass over volume, right? And then you have input, output, force for mechanical advantage. For example, with a lever, input arm distance, output arm distance. And average acceleration and your gravity. Now, let's see. You have 30 multiple choice. I read every one of them to you when we were outside.
I can't hear you.
Oh, yeah, they get here. They're welcome. Yep. You have matching. Your matching is going to give you your, now listen here, your matching is going to give me your Newton's laws, and it's going to give me your thermodynamics and a couple of the other principles and laws. So when you get to give an example of Newton's first, second, third law, if you know that you've correctly done the matching, then you probably don't need to write out Newton's first law states that blah, 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 and it can be observed when. You can just say Newton's first law can be observed when. But if you say Newton's first law can be observed when, and you're getting the other ones wrong, Like I'm gonna look back and be like, you know what I mean? So just be sure that you're being clear, and I know what your intentions are with everything. Always be sure I know your intentions. You will have that one I read outside with all the excess information on it. Know how to weed out what's necessary and what's not necessary. You're gonna be asked if given the voltage, you're gonna be asked for voltage given resistance and amps. Okay, and these math are 2 points each, okay? So you got one with all the extraneous information that's basically asking you for average speed. You've got one that's asking for voltage when given resistance and amps. You've got one that's asking for displacement when given direction and distance. You've got another that is asking for acceleration when given the mass and the force in the direction. You've got another that is asking for distance when given work and force. You've got one that is asking for power when given joules and time. Okay, there's a random little comma there that doesn't belong in that sentence, but don't come tell me about it, I already know. And you've got, let's see, you're gonna have to give me the density of an object when you will be given its volume and its mass. You're going to need to give me acceleration when given mass, net force. You're going to need to give me average acceleration when given distance per time increased to distance per time. So if it goes from 3 meters per second to 12 meters per second in 3 seconds, what is your average acceleration? And you're going to have to give me the value of G, just give it to me. And you're gonna have to give me mechanical advantage involving a ramp, distance, and height. You're gonna need to complete your little diagram. And let's see. What I do? I need to color that appropriately. You're going to need to, like I said, label your lever diagram. You're going to need to label, do y'all remember the little diagram? I'm not sure if this was in the slideshow. I don't think I saw it. You know the little diagram with the volts, amps, and ohms where the looks like a cowboy lassoing somebody through a little tiny narrow. It's the one that looks like that.
Nope.
Yep, this one right here. Look at that one. You're gonna need to tell me what they are. One's the volt, one's the amp, one's the ohm. You're gonna need to label a longitudinal wave and a transverse wave, okay? And you're gonna need to give me your variables. You're gonna need to give me your unit prefixes, metric prefixes, examples of, as I said, Newton's first, second, and third law, and examples of light. Think about light as wave and particle. You're gonna need to give me one or the other. And you're gonna need to give an example of Doppler effect. What's an example of Doppler effect? Somebody give me one. A siren passing by. What's an example of light as a wave? When can you see light as a wave?
Light as wave,
Yeah. Like a what?
like the UV flashlights.
Flashlights, yep.
Nicholson's experiment,
Nicholson's experiment, yep. How about just color in general, right? As opposed to light as a particles when you're gonna see like beams of light, right? Yes, that kind of thing. All right. Let's see. You guys know your scientific theory and scientific law inside out. Good. You know your why is science never settled inside out. Good. Tell me about, you're gonna, again, that pitch and color thing. Be sure you know pitch and color. Pitch is given, pitch is the perception of what?
Frequency.
Frequency of a sound wave, and color is the perception of what? Wavelength of a light wave. Yep. And that little bit about salt, water, and ions.
Do you have to know what color is more condensed and which is more far apart, or
Which what now?
do you have to know if like what how frequent the red waves are compared to like the ultraviolet waves?
No,
Okay.
no. I actually don't have the whole electromagnetic spectrum on this one. Science smackdowns, and then, like I said, there's a lab practical as one of your bonus questions, okay? And it's one where you're gonna have to look at a phenomenon, look at it, and then you're gonna have to explain what's happening. You're gonna be able to touch parts of it, not other parts of it. Are you embarrassed? Because you should be.
I didn't see him. I looked underneath and I actually, it took me a solid 20 seconds before I.
Fabulous.
He was so, like, he was in the corner. kind of-
So be sure that you go into Teacher Ease and complete the assignment for pizza. You gotta tell me which one you like, so I know how much to order. And then you gotta either Venmo, PayPal, or bring me cash for pizza next week. Now, Yusuf sent me like 12 brownie points that some were questionable. And then I got a brownie point from his email. You had an error. Anyway, I should have canceled those out, but it didn't matter. So I'm gonna add brownies to the cupcakes and pizza, because whatever at this point. So the way I'll put it in your email. My goal, guys in the back, my goal is to give you 15 minutes to set up next week, which should give you time to do any last minute runs, error checks. And then we'll run at random. I think I still have this. Maybe I don't. We'll run at random. Okay. So, anybody have any questions before y'all move? You good? Study. Do the slides.
Would it be possible to do my transcript first, so I can submit that?
It will be done by noon the next day. It's already prepped. I just need
I don't
your,
know if my mom already talked to me about that.
no, all I need is your final for this class and then I'll run it out. You'll have it by the next day.
Thank you.
Yeah, is that gonna be enough time for you? Okay.
Yeah, because I just have to then submit that transcript.
What's the rule for Hope this year? Because they change the score every year. It used to be an
That's like
SAT
been
score.
pushed out.
Yeah.
And so, yeah, it's SAT score, and I think it's actually GPA this year. You
Really?
have a certain GPA, which
See,
I have.
I would love for it to have been that.
And then it's, I think it also, you go in with it if you have a certain SAT score, which I
Just barely made. Yes, then you can hang on to it. It
Yeah.
used to be like they would pay it only retroactively.
Yes,
Is it still?
I don't know.
It's crazy.
Yeah, okay, thank you.
Did you have a question? You're looking at me like you do.
I just wanted to thank you for sending that letter.
Okay, yeah.
Anytime. I love writing reference letters.
Oh, I'm here.
I don't think you. No, Caitlin, you got coins, girly.
I've already requested out time for this week.
Then it's only brownies for the.
Yeah, but they're just like me. And by the time you get ready to get it, I'm still done. Right.
It's my coins.
So comes a bit of showing.
The coins don't really matter anymore.
I can get anything.
Did you answer any questions?
I thought I did.
You can.
Oswald, what you doing? See most of y'all on Friday. Most of y'all at the dance. Not everybody. I don't think.
Ozzy was trapped under